Based on these vision, use case working group has worked at the prospective use cases, collecting proposals from member companies that will require utilization of ultra high bandwidth, low latency, and with computer integrated network, where IOWN is aiming to provide. And in October of last year, despite of this pandemic period, we were able to release documents describing the use cases and highlighting key set of requirements to enable each of the use cases. We choose to split the use case into two categories, one being the cyber physical system, collecting use cases leading to leaping beyond human cognition and prediction, enabling autonomy. Other one is called the AI integrated communication, where a collection of a use case leading to human-centric, life-enhancing human augmentation applications. These documents are available for the public and can be found in our homepage. So please visit the site for the details. Here we take a look at one of the use case, remote factory or remote operation use case. Idea, of course, is that you want to operate the manufacturing process without physically being in the factory. Very simplified example figure indicating site A being the physical factory and site B being the remote site. Ideally speaking, you would like to have all spatial information of site A to the site B so that you feel as you are physically working at the factory. And in order to do that, multi-angle high-resolution video to construct 3D model is needed from site A. And in order to provide view-dependent 66 degree of freedom 3D video image, you need to collect eye and head tracking information from site B operators, and then render the image to match with the viewport and deliver it back to site B. And all these need to be processed in very low latency manner with high immersive resolution and accuracy. When we look at the multi-angle high resolution data, we are looking in the range of 20 gigabps. We need high performance computing power to reconstruct 3D model. And what we see as the most critical requirement is that what we call motion to photon latency, where less than 20 millisecond round trip latency to achieve eye track, render the viewport dependent 3D image, and transport back to site B. So all in all, when we look into these use case requirements, obviously we see large gap implementing this scenario with current state-of-art technologies in terms of bandwidth, latency, computing power, and being real-time and interactive. We, as a use case working group, we define these gaps and work with the technology group how to fill the gap in very detailed manner so we can showcase the technology with appealing, profound use cases targeting the various industry domain.